So in part three, we're continuing off of where we were. So we just talked about Docker at the top here, but we neglected to talk about the infrastructure and the operating system that we need, that Docker is going to be running on top of. And so that's what we'll talk about now. And specifically, we're going to be using this operating system called Flatcar Linux. It's a Linux variant, and Flatcar Linux is specifically designed to run Docker only. And here's kind of an overview of what our deployment is going to look like. From the outside, we're going to be using AWS as our cloud provider. So this is, a company that is providing us with the tools to deploy various infrastructure. The infrastructure specifically that AWS gives us, they have an offering called EC2 or Elastic Compute. And this essentially allows us to spawn a machine, if you will. It may or may not be a physical machine in one of Amazon's warehouses. It might be a virtual machine on one of those physical machines. We're going to run Flatcar Linux on that machine that AWS gives us. And then Flatcar Linux is going to run our Docker Compose that we set up, and Docker Compose runs our applications, including an Nginx web server and a Postgres database. So Flatcar Linux, just more in depth about this operating system. Again, it's a containerized, optimized operating system. It has the bare necessity to only run containers. The operating system does not have anything else. And it has an immutable file system, which means the file system cannot be modified really at runtime. And updates happen automatically. This is very good from a security standpoint, so that if someone were to make their way into the system, they can't really modify anything because things are mounted read-only. And in terms of staying up to date, there's no manual maintenance required. These updates will be brought in as they come out and as they're stable automatically into the system. It's turnkey in the sense that they have documentation on how to deploy in many different cloud providers. You can see a list of them: Amazon EC2, Azure, Google Compute, Equinix, VMware, which is virtualization platform, DigitalOcean, OpenStack, Hetzner. So a lot of different providers can run this. And then it has this YAML configuration, somewhat like Docker or Docker Compose has their own configuration specifications for setting up the system. Yeah, so that's Flatcar Linux. It can also be run on bare metal from ISO if you were to deploy this there. The next thing that I mentioned was AWS. So AWS stands for Amazon Web Services, and Amazon Web Services is I think one of the older cloud computing, if not the oldest cloud computing software provider, and it lets you access these compute infrastructure. So CPUs, GPUs, memory, disk storage on demand all over the world. So this is just a look at some of the regions that AWS has data centers in. And with some pointing and clicking or a few CLI tools, you can launch machines in any one of these places, which is both very good and also kind of bad if someone accesses your account. So they offer some simpler resources, just like bare machines, raw storage, and they also offer very high-level managed resources like certain databases and even AI tools, like launch your own language model and use that. And with Amazon, you basically pay for what you use. So you can just spawn, hundreds of machines, and you will pay for all of them, or you can spawn a very small machine and pay pennies on the dollar for it. But again, because you can launch these resources very quickly, I implore you to exercise extreme care with your credentials if you end up using AWS. This is a screenshot of the AWS console. So when you log in with your user, you get these like recently visited sections, and they have a bunch of different services, as I mentioned, and they have names for all of them. So Elastic Compute, I messed this up. It's EC2, not E2, but EC2. And again, this is just for configuring and launching like bare machines with really nothing on them, but you can specify an operating system, as you'll see. There's IAM, or Identity and Access Management. If you create credentials to access your account by API, IAM is where you do that. There's another useful service called Simple Storage Service, or S3, which has a place for resilient and easily accessed file storage for uploading files or allowing people to download files from there. I won't really use this when I deploy, but this is something you may find useful in production applications. Similarly, there's the Amazon Relational Database Service, or RDS, which is a database offerings managed by Amazon. They also manage other types of databases that they have under other names. And I would recommend, if you're going to production, to eventually adopt these types of databases, because Amazon will do backups periodically for you. They'll make sure that you can roll back. They'll tell you when there's updates. So it gives you a lot of benefit, but it does come at an extra cost. So to launch and deploy something with AWS, we will use this EC2. And so from EC2, you'll be able to find a button that says launch an instance. And when you do that, you'll get presented with this interface. And you can see that you configure a bunch of aspects of the instance. So the operating system that's going to run on it, they call an AMI, and you select this, which I'll show in a little bit. You have to specify the server type. So Amazon has all these fancy names. In this case, this is T3.medium, but they have an entire listing of what these things mean. Generally, there's micro, small, medium, large, extra large. And that's just referring to, bigger or smaller, like the number of CPUs and the amount of RAM you have access to. And then the left side has some meaning with the architecture of the chip and also the hardware that's there. But you really have to consult with their site, because those things change also. You have the security configuration for the instance. So when you spawn the instance, you can spawn it to not be accessible to the outside world, or you can say you do want it accessible to the outside world. And then you also have a hard disk, so the physical storage you're attaching to your system. So all these things have to be specified. One thing I will note is that if you're planning to run a website, you need to make sure you click these things. SSH traffic is essential so that you can access the system via terminal. HTTP and HTTPS need to be checked, or otherwise you're not going to be able to access the site because the firewall will block it, basically. So to actually do this deployment, we're using Flatcar Linux, remember? So what you do is select this Flatcar Linux. From that interface, you'll type in Flatcar, press enter, and then it brings you to this interface. You can select these. Honestly, I've not found any difference between the Pro and the not Pro. They both cost the same amount, $0. Make sure that you have the right one. But once you do that and click subscribe and launch, then you go back. Yeah, it brings you back, and then you continue. So to proceed, to actually deploy this thing, we're going to need to configure Flatcar. So remember that Flatcar is just an operating system designed for running containers. But basically, Flatcar is set up with a configuration that will tell the operating system what to do when it boots. So this is the Flatcar configuration process. First, you'll want to just download this gist that I've prepared for you, which has a basic Flatcar configuration set up already. And essentially the two aspects that are most important are this section, which creates a user so that you can log into Flatcar. And what you have to do is use this SSH keygen to create a cryptographic key. And then you'll use the public key and put it here. And when you do that, this is going to allow you to use SSH from your system and connect to this Flatcar instance once it is launched. No one else will be able to access it because this key pair, using similar technology to TLS, this is generating a private and public key pair, and we're giving the public to the instance. So that's the common secret, if you remember from before, with the paint. And then the other useful part is the Docker Compose. So we talked about Docker Compose in the previous section. Whatever Docker Compose you develop on your own system, test, and have your application running on, you copy and paste that over here, and then this deployment will be usable for launching it in AWS. So just a little more to show you like how this configuration is working. So there's this section that basically runs the Docker Compose command with the Docker Compose you specified and just puts it up. All right, that's how it's working. Very simple. And then how does it have Docker Compose? It has to download that binary and verify it from GitHub. So that's pretty much the gist of it. Flatcar will boot up, it will download Docker Compose, install the binary, and then it will use that binary to run the Docker Compose that you specified. Yeah. So once we've done this and we have this configuration set up from the gist, this is a Flatcar thing, but you copy this command, and when you run it, you're going to get a JSON document. Essentially what it does is it just validates and normalizes this YAML file that you give it, and it gives you JSON instead. And that JSON goes in the user data. So from before, remember we started, we specified the disk size, we specified the operating system. So now at the bottom in the advanced details of the Amazon interface, we have this user data, and that's what we paste here. Right, and it has the same information from the YAML. It has the, Docker Compose will be running. It has our public key, and that's basically it. So once we do that and launch it, then we'll go to the EC2 instances. We'll be able to find it. So I called it Hello Web. And then when you click it, at the bottom, it will have the details. One of them is the public IP address with the DNS, or even just the IP itself. And if you open this, like by clicking Open Address, after it's been running for a tiny bit, you'll visit it in your web browser, and this is what you'll see. You'll see the default Nginx based on the gist, or if you actually put in your own Docker Compose with your own application will appear here. Another thing that you'll be able to do is SSH into it with the username core, which was specified in the Flatcar config. And assuming you did the public key part properly, it will let you write in, and then you can have shell access. And that will be useful for like checking the logs of your application. So we have deployed a site to AWS, so you can use this gist and you can do this. You have an AWS account. But this is currently not secure, and Chrome tells us this. So how do we make it secure? So one thing about making a site secure is you need a DNS, you need a domain name. And one way you can get one is with this thing called DuckDNS. So DuckDNS is just this free DNS provider. You can go to this site, create an account with like your Google account, log in with Google, GitHub, Twitter, what have you. So once you've logged in, you're going to get this token, and here you can register an arbitrary domain, and it will be something.duckdns.org. So once you've done that, it will, become a record here. And the nice thing about this DuckDNS is you can just specify the IP, say update, and then that domain will point to that IP. And actually, you can modify the gist a little bit, and the gist has that. If you go to that link, you can tell it to actually update this. So you're going to get this token. You can put it here. You have the domain that you specify that you came up with to call your app. You can put it here. And then what this will do is once the system has started up, it will execute this command. And what it will do is update the IP address on your record. So that will set up your domain name. But then you need, for HTTPS, you need to prove that your domain, you own it. And to do that, you can use something called Let's Encrypt. And also in that configuration, it shows you how to do that. The main thing you need to do is put in your email to this argument of of the gist. And then you put in your domain.duckdns.org. So when you've done that, it will automatically get a HTTPS secure a URL, and then your site will become HTTPS compatible. And then this, I also set up this like cookie cutter, which will set up your Flatcar config pretty quickly for this. So you can actually try that as well and speed up the process. So that works with this command cookie cutter. You can Google how to install that. And then it's this particular cookie cutter. It asks you some questions, your public key, the domain you want to use, the token you got from DuckDNS, and then your email. And then it will create this ignition.json that you copy and then paste into the user data when you launch the EC2 instance. And then this is just an example of what that looks like. So I have this minelabtest.duckdns.org, and I launched this, and I successfully have a secure site hosting the default Nginx container. If you were ever to go beyond this and reserve your own IP address, this slide might help you with that. So you need to first reserve an IP, then you need to buy a domain. So DuckDNS is free, but if you want like something.com, you need to pay for that. Doesn't cost too much money, but it's like $10 a year with the uncommon domain. And when you do that, you then have to create the record. So Amazon can let you do that. There's other services, other DNS services that you can do it, but yeah. So that's kind of it, right? Now that we have this gist and we know how to use Amazon EC2, we can deploy with the help of Flatcar Linux some arbitrary Docker compose that is set up to run your application.